moderate the first session for today. My name is Gabriela Teodorescu, and I'm from Valahia University of Târgoviște from Romania. And together with Professor Sanjay Swami from Central Agriculture University, Imphal, India, he is the co-chair of this session. Try to share with you very nice moments and very scientifically. This field, sustainable agriculture, organic farmer, and agrobiodiversity, I think there are subjects important for all of us, because all people need food, need clean food, need to live in a clean environment, and to have the assurance for a very good life. So for me, and I think, and I'm sure that for Professor Sanjay, will be very, very happy to moderate all this session, because we will start with a prestigious specialist from different countries, from Tajikistan, from Bosnia-Herzegovina, from Romania, and of course from India. So we will have information about this field regarding the agrobiodiversity and sustainable agriculture from all over the world, I can say. And I am sure that the information will be very, very fruitful for everybody. To not lose much time, because Professor Hafiz have the first presentation, let me have a short presentation of him. So the first presentation will be made by Professor Dr. Hafiz Muminjanov. Professor is agriculture officer for Food and Agriculture Organization of the United Nations, located in Rome, Italy. Also, he's a doctor in agriculture science. The title is obtained in Russia. And also is a professor in Tajik Agrarian University in Tajikistan. Professor Hafiz graduated the Tajik Agrarian University. He have more than 30 years experience in the field of agriculture and rural development. He worked for national, international organizations, as Asian Development Bank, IFAD, and so also. And we will be very happy to hear from him all this experience. Also in 2010, he was IFAD country presence officer in Tajikistan, with big responsibility, I suppose. And also have a good experience in and a lot of experience in conservation agriculture in that regions. During his experience and his jobs, established many partnerships with non-governmental and non-commercial organizations in Central Asia. And support also participation for young specialists and scientists. I think one of the most important role of us as a professors is to prepare other generation, new generation of engineering scientists, because as I said from the beginning, all of us need clean food and clean environment. So we need to share our experience and our background. So thank you very much, Professor Hafiz, because you are here with us. And now I give the floor for the first presentation. Thank you.
Good morning. Thank you very much, Madam Chair. Professor, thanks a lot for excellent presentation and also for inspiring notes. Dear colleagues, today I will present very interesting topic. Maybe it's conservation agriculture and dryland farming. So yesterday we were talking about the importance of mountains, and today I will say why we should work more on drylands. So drylands, drylands are occupying more than 43% of the area of the globe, and more than 2 billion people live in drylands, and most of them are living in the developing countries. And you may understand the situation in developing countries. They're facing difficulties in food shortage, on malnutrition, and there is also a problem with water scarcity, poverty, biodiversity loss, recurrent droughts, environmental degradation, and all these problems are becoming more increasing due to the climate change. And most of the farmers in the dryland, they usually practice monocropping and tillage-based farming systems, and overgrazing is common in the dryland, and farmers are lack of appropriate technologies and risk management strategies. Taking it into account, FAO has formulated the global program on sustainable dryland agriculture that is a core component of a new FAO initiative on hand in hand. So the general objective of the global program is to achieve sustainability. It is environmental sustainability, it's social sustainability, and economic sustainability. So you may see that the objective is to improve food and nutritional security, first of all, then improving livelihoods, environment in dryland by strengthening capacities of stakeholders. So the program is targeted to the low and mid-income countries. Also, it covers low capacity countries. The first term is 5 years, it's a medium term, and also we have long vision to extend implementation of the program. The program has 4 key pillars, 4 thematic pillars. The first pillar is preparing a data platform with a toolbox for assessment and integrated decision making. Also, there is a thematic pillar on assisting countries to provide enabling environment for policies, strategies, investment, and partnership in the dryland. Important component is capacity development, strengthening institutional infrastructure and services, and also knowledge sharing. So we are mobilizing resources through different donors, private sector, government, and also mobilizing resources from FAO regular and technical cooperation programs. So through implementation of this project program, we work on developing portals and linking them with other data platforms. So, and use available assessment tools, networks, initiatives, and FAO, like WASAC is Global Framework for Water Scarcity in Agriculture, Global Soil Partnership to use as a platform, also LADA is Land Degradation Assessment in Dryland. It's an interesting tool. And another tool is Dryland Sustainable Landscapes and Green Cities Initiatives, WOCAT. Other tools are the initiatives available in FAO and also other developing partners. They will be intensively used in the implementation of this global program. So for the toolbox, I will tell you more in details. Our idea is to gather the innovations, potential context-specific and low-cost technologies, tools on improving sustainable use of crops, soil, water, livestock, pasture, forest management into one toolbox. For instance, integrated water management, agroforestry, crop and livestock, diversification of cropping systems, and all together will contribute to achieving sustainable dryland agriculture. So the examples of the toolbox are presented in these slides, and I can give you a few examples also. For instance, protected and precision agriculture. In the drylands, we know that water scarcity and disease and pests are the problem. So using protected cultivation and precision application of water, pesticides, fertilizer will allow to increase yield with lower cost. So this is a potential, and we are promoting this approach in the dryland. You can see that also application of hydroponic systems allow to produce nutritional food and feed, not only for food, not only for people, also feed for the livestock. So another example is enhancing biodiversity. So by diversification of cropping system, introduction of new crops, new species, new varieties into the cropping systems. And another clear example is cactus species. So cactus now serves as a source of food and feed in drylands, and it's used in many industries, and it can substitute cereal grains, and it provides more energy to the camels, to the livestock in drylands, and increase also milk yield. And today, over 2 million hectares are occupied with cultivated cactus, and we have more than 3 million hectares under wild cactus that could be harvested. And the new modern in vitro techniques also allows for rapid multiplication and dissemination of cactus in the new areas. So another area is integrated water management. So started from very simple techniques like this one, drip irrigation, with using tank and gravity irrigation, using subsoil irrigation, bed planting, other methods of improved water management can be applied in the drylands to improve production. So another example is digital and precision agriculture. So we are moving forward and using drones, using other sensors to improve production system, to ease the job, to provide more decent job for the farmers, to ease the job, and to produce more food. Here is another example of using water boxes. Water boxes are becoming very popular nowadays in many countries around the globe, especially in the drylands. So these are very simple boxes where you plant the tree, for instance, and you water once, you fill up to 50 liters. So the system provides sufficient amount of water, and it also harvests the water from the condensation and also from infiltration from the soil. So this is another approach that could be used, and there are evidences that the technique can be used for establishing huge plantation and forests. So also we promote through Dryland program different integrated approaches like crop and livestock, agroforestry approaches, because to diversify production, to use integrated approach. Also, we consider that our Dryland program will contribute to the UN Decade on Ecosystem Restoration, taking into account rangeland management, ecosystem restoration techniques. And also, we do not forget about social, cultural, and traditional issues, especially gender aspects, cultural aspects in improving lives in the drylands. An important pillar of the program is providing enabling environment, so supporting countries in conducting studies, assessments, strengthening policies, strategies to improve dryland farming. One of the tools, important tools in improving dryland is conservation agriculture. What does it mean? Maybe you heard it already about no-till system or zero-till. It's also very popular with these names. So it has 3 pillars because only no-till cannot work. It's not sustainable. We will be talking about sustainability today in this session. So therefore, at FAO, we promote conservation agriculture with 3 key principles. The first principle is no-till or minimum mechanical soil disturbance. So planting, weeding, fertilizer application without soil disturbance. And second principle is soil should be covered by organic matter, at least 30% of residues or should be remain in the soil surface, and also we have to enhance cropping systems by growing more cover crops to retain residues and to the soil. And the third principle is to avoid monocropping, to promote more diversified cropping system. So in each crop rotation or cropping system, we should have at least 3 different botanical species. Of course, techniques, machineries are also modifying. We have job planters, we have small scale equipment and large scale for promoting conservation agriculture in the field. So the main principles, again, I would like to repeat myself, is minimum soil disturbance. It's no-till. It's not minimum tillage. It's minimum soil disturbance. It's no-till and permanent soil cover with crop residue or with cover crop and diversification of the cropping system. These are the 3 main important principles of conservation agriculture, or CA. And it enhances soil biota. It improves soil fertility, soil structure, soil mechanical features. So how does it work? How does CA work in the theory? So usually before planting crop, we do mechanical tillage. So, but CA talks about no-till. So it means we move from mechanical tillage to biological tillage. So through no-till, we provide more room for soil biota, for microorganisms living in the soil to work to improve soil structure, soil health, soil porosity. So it also improves soil water holding capacity. It can improve also, it is very important in the drylands. Also, it reduces the temperature, soil temperature in the soil cover. Also, it allows to keep more carbon in the soil, so it increase organic matter in the soil. So the system is rapidly extending or promoting in many countries. So you may see that it started from in 1930s in US and also in Kazakhstan, in Russia, and there were attempts to promote CA or no-till system. So today, over 2 million hectares are under CA system. It makes about 15% of the world's annual cropland, and more than 100 countries you can see in this map in different agroclimatic conditions, in the dryland, in the tropics, subtropics, in the mountains, also smallholders, large-scale farmers in continental climate, in dry climate. They are promoting, they are applying this approach, and they are very happy and satisfied with this. But what were the driving forces for adoption and promotion of CA? First of all, it's soil degradation. This is, I mean, the CA, we always say that this is a farmer's invention. No one can claim that we developed or we are the author of CA. Farmers themselves, they had to promote CA because of these driving forces like soil degradation, like recurrent droughts, water scarcity due to the climate change, and the storms, desertification, and also there is an economic driving force like rising input price, fuels, or machinery, maintenance, and also commitment of the government to the international agreements, like to the agreement on climate change, and focusing countries more on sustainable production. So it's not easy to adopt and promote CA in the farmer fields. First of all, because of the changing mindset of farmers, it's very difficult. Not only farmers, also researchers, policymakers, they have to shifting paradigm from tillage to no-till. It's not easy. And also there are lack of policies, strategies, lack of proper set of equipment, knowledge, extension system requires more work, and also financial mechanisms, financial support is needed, and curriculum trainings in the universities, in the vocational training would be needed. What are the lessons learned? Because FAO has been promoting or assisting countries to promote CA in many countries, and I would like to share with you a few lessons learned during this implementing the field projects. First of all, we realized that no-till will start not during the planting. We have to start during the crop harvesting, so we have to keep retain residue on the surface. We have to chop and we distribute evenly, and also time to time we have to do deep subsoiling to remove the plow pan. So it's not till just in this picture you can see that the subsoilers are used to remove the plow pan, that also to improve in soil infiltration. So residue retention is important. So very often farmers have a dilemma. They should feed the cow or should feed the soil. So they have to understand that for sustainability, for future generation, they have to return to the soil also part of the let's say biological biomass that was produced by the crop. So this is important. Also, we talk about CA and conservation agriculture and CA chemical agriculture. Our experiments and working with the farmers assured that CA is not chemical agriculture, because we retain the residue and it allows to improve soil biota, and you can see that the life is back to the soil. Because some opponents of CA, they criticize that CA promotes pesticide application, herbicide application, but it's not true. Maybe from at the beginning for no-till, maybe there would be the need for applying herbicides to suppress the weeds, but further, when we have mulch cover on the soil surface, it allows to suppress the weeds. So most of the farmers like CA or no-till because of economic reasons, because they start saving. But we have to explain them that there is the need for more sustainable thinking, having proper equipment, proper seeders to keep no-till, not minimum till, to think about soil has soil properties. So in regard of the equipment, most of the equipment are very large, but we work with the small scale farmers. So we have to think more about producing equipment for the small scales. So most of the equipment we have are very heavy, they're not suitable with running with the small tractors available. So there is a need for developing small machinery, hand planters, for the small scale and family farmers. And also there is a need for developing and production of seeds of cover crops. There is a lack of seeds of cover crops. Also, there is a lack of special machines for planting the seeds of cover crops. So you may see that in this motorbike, they're just spreading the seeds of cover crop, and here chopping and pressing the cover crops or crop residue, and also from the top planting the seeds of cover crop. So another area is application of chemical. It's very important that all equipment to be used in agriculture is CA or other type of conventional agriculture, or even for sustainability, we have to pay more attention for to use proper equipment and to use regulation for safe application of the pesticides. So this is FAO has published many guidelines for minimum requirements of agriculture pesticide application equipment. We have to follow these rules and procedures. And also there is a need for production of more guidelines, manuals for farmers, for extension specialists, for the students' curriculum, for the researchers, how to carry out studies, research on CA and how to improve production. So also the need for establishing regional alliances, associations, farmers associations, and establishing platform. For instance, we have this platform in Russian for Central Asian countries, where different countries come together and they are sharing knowledge and experiences. In conclusion, we may say that the Drylands important area for improving life, improving food security, livelihood for the population, especially for small-scale farmers, for rural family farms. Therefore, we have to pay more attention to development of dryland agriculture. And conservation agriculture, or CA, could be one of the options to develop dryland agriculture, and it could be adopted in many types of soil and farm types to mitigate and adapt to the climate change. Also, it's not easy to promote to scale up CA in the farmers field, because there are many constraints, difficulties, like lack of proper field equipment, weak agriculture extension systems. Also important that there is a need for changing mindset of farmers, politicians, policymakers, researchers, extension specialists. So, and also there is a need for maybe starting modification of existing equipment. And also SAA cannot work alone. So it should be integrated with other good agricultural or agronomic practices. So like organic farming, like integrated pest management. Also, there is a need for political support, developing strategies, strengthening institutions, training a wide group of stakeholders to get support for promotion of the CA, and also having a suitable environment to have colleagues and more people who may understand, may come together, support promotion of CAs through establishing association, developing technologies, and providing services and networks. So with this conclusion, I would like to close my presentation, and here is my email address. Please, if you need any question, if you have any question, if you need any further information, please do not hesitate to write me. Thank you very much.
Thank you very much, Professor Hafiz, for your wonderful presentation and very interesting information during your presentation. I think our students from summer school will be delighted to read your material. And indeed, it is very good opportunity to share the experience from different parts of the world with different point of view regarding this sustainable agriculture field. Thank you very much for your contribution and for wonderful presentation. Now I